to another Python tutorial. In this Python tutorial we're going to be going over a binary calculator that I had to develop earlier this week for one of my assignments. Obviously I had to convert it into C++ code after writing it, but because it was actually a hardware assignment where I had to develop a binary counter for a microcontroller and display it on the screen. So it worked a bit differently, it worked in C++. But nonetheless, we're going to be going ahead and programming this. So we want to go ahead and define number equal to 10. And we're going to want to go bits equal 8 and bin underscore list equals empty. And so those are our starting variables. Now we want to go ahead and define our binary calculator, so binary underscore calc. And inside here we want to set our count to bits. We want to set our, we actually want to pass in, no that's fine, we want to define a string equal to something. So it's empty at this stage, it will fill up later. And while count is less than 0, is greater than 0, sorry, it will run. So now what we want to check is if number is divisible by our bit. So we want to go if number is divisible by count and it's equal to 1, then string equals string plus 1. Otherwise, if it's not true, then string equals string plus a 0. Now going into here we need to go number minus equals count, because we want to remove that number that's being changed here. Now we also need to pass in number, because otherwise we're going to have a problem there. So we're going to remove the bit that we've currently divided by, because obviously if 8 goes into, if we have 10 say, and 8 bits is divisible by, 10 is divisible by 8, which it is, then we want to take that 8 off, because we've set a 1 to that position, and now we're checking against 2. Okay, so now when we get to the bottom, here we want to go count equals count divided by 2. Now the double slash means it's integer division, and so we won't get a float, because the float throws an error when that happens. And we also want to go bin list dot append string. We want to pass string into that list, and then we'll print bin list. Alright, so we can go ahead and run this now, and we should get 1010, because 10 is 1010 in binary. So let's go ahead and test that. Just before we go ahead and do that, we also want to go and add a binary calc call and pass number into that. Alright, so as you can see here, this is the list output we get. Say I add another number in there, then I'll add 5, because I know that is 0101, and you'll see we get 0101 for 5. So that is 5 in binary. Going back up to the code, we're going to want to now do an anti-binary calculator, so we can calculate from binary, pass it a binary value, and it'll calculate it back. Alright, so to do that, we want to go ahead and define another function, anti bin calc, and we want to pass that the bin list, because we're going to convert what we have in the bin list back, just because I feel like doing it that way. Alright. So now inside the function, we want to go ahead and go for I in bin list. Count equals 1. Total equals 0. So this is going to, every time, if say there's 10 items in the bin list, it'll do a calculation for every single one of them in there. So for x in range, length of I, so how many items, this works out how many items there are in that string. So obviously in the case of an 8-bit number we've got 4, but then it can calculate up to say 100 if we had 100 bits in it, or whatever. It just doesn't, it's not size isn't relevant, it just calculates it until it reaches the end. Minus 1, so it stops it going out of range. Minus 1, minus 1. So this is, it goes from the minus 1 position on the length, because a list goes from 0 to the number below, sorry, no, yeah, the way item storage works is it goes 0, 1, 2, 3, 4, 5, 6, and so if we go length and it's 6 long, we'll say 6, but in storage wise it'll be 5. So the minus 1 takes off so that we have that 0 to 5 and goes to minus 1, so it's at the 0 point and counts in minus 1 as well, so it's counting backwards using a for loop. Alright, so if int of I x is equal to 1, total plus equals count, and count equals count times 2, and then at the end we want to print total. We also then need to go ahead and call the function, so we're going to go anti bin calc bin underscore list. So originally we're going to get 10, so what we should get is we should get the 1010 list and the 10 output underneath that, and then we'll change it to 5, we should get the 0101 output and a 5 underneath that. So let's go ahead and test that. Alright, so running this now, you can see we get the 1010 and 10. If I change this to a 5, then we'll get the 0101 and a 5 output. Now I want to pass a new, actually the way we can do this is let's highlight up everything, everything here, and we'll run in console, execute section in console. Okay, so now what we can do is you can see we have our item here, and we can call these functions passing in numbers. So I can go binary underscore calc, and I can pass in, say, actually no, this won't work this way because we don't have it passing in the correct amount of bits. So this way it won't work for that. But we can go anti bin calc, and I can show you how it takes the length doesn't matter. So we can go 110101010001, and it'll still calculate that out. And if we go ahead and remove some off there, you'll see it still calculates it because of this for loop here that runs from the length of I to the 0th value. Now if I quickly go ahead and change the way that binary calc works, then I'll be able to run it in console too. Copy, execute in console. Alright, so now we can call binary underscore calc, and we can pass in how many bits you want. So let's go 128 and pass in the number 30. Let's go 124. 124. Oh, my bad. I put a slash in there. Oh, what happened there? Bin list is not defined. Oh, yeah, that's also a problem. Because we don't have bin list defined here. So what we can do is we can go ahead and execute this in console. See if we can still bring that thing back. Nope, okay, we can't. Okay, so binary underscore calc 128 bits, and we'll pass in what's it called, 137, and you'll see there it calculates 100, the binary value, and we can pass it in again and calculate, say, 256 bits, and we'll go say 300. It'll also calculate the 300th value with an extra bit on it. So yeah, that's how my binary calculator worked. I'll take you back up to the code. But yeah, this isn't converted into C++ obviously, and I'm not going to do the conversion due to the fact that it's even for an assignment. But yeah, thanks for watching, and I hope to see you next time. Bye bye.
Alright, hello there guys. You've obviously made it to the end of the video, so you've obviously enjoyed it or had to watch the whole thing at least. So if you could consider subscribing, that would be a great help to my channel. If you have any suggestions for future videos, make sure to drop them in the comments below. Like the video to show your support to me so that I can know whether you like the content that I'm making. And yeah, hope to see you in the